Okay, I think I'm going to do just one video for the last two topics for this worksheet. So topic 3 is additional applications for the multiplication property of equality. So in the previous worksheet, we were doing the addition property of equality, and we got to the point where we had practiced the addition property of equality, but then I gave you a couple of equations that were a little more involved that needed some simplifying before we could get to that point where we could apply the addition property of equality. We're going to do the same thing here, okay? Ultimately, when we get into the next few sections, we're going to really start solving much more complex equations, much more complicated equations. So you need to get used to that idea of simplifying and then applying your properties. Okay, so this example 3 says simplify both sides of the equation and then apply the multiplication property of equality. So let's get started. So for part A, we have 2x minus 12x equals 40. So what we want to do is look to see if we have any like terms on either side of the equation that could be combined. We have that here. 2x minus 12x, we can combine that. They both have the x term, so let's get it into a single term. So 2x minus 12x, we just want to take 2 minus 12. I'm going to remind you still for a little while longer some of the steps it takes to add, subtract, multiply, and divide, but I really do want you to get to the point where you can just be like, 2 minus 12 is negative 10. But in case you forget, subtraction can always be rewritten as addition. We do that by keeping the 2. Instead of subtracting positive 12, we want to add negative 12. These are equivalent statements right here. And then when you're adding two numbers with different signs, you subtract the absolute values. So this is going to equal 10, but we have to ask ourselves, is it going to be positive or negative? Well, I've got two positives, but I have 12 negatives. I have way more negative than positive, so this is going to be negative 10. So the left-hand side here simplifies to negative 10x equals 40. And then at this point, we have a single variable term equaling a single constant term. We're at the point where we can go ahead and apply the multiplication property of equality. So I need to undo what has happened to x. X has been multiplied by negative 10. We undo multiplication with division. So I'm going to divide both sides by negative 10. If I don't divide both sides by negative 10, I lose the balance that's naturally there in that equation. So whatever you do to the left, you have to do to the right. Okay, so on the left, negative 10 divided by negative 10. So any number divided by itself is positive 1. So we get positive 1x. We don't write the 1, we just write the x. And then 40 divided by negative 10 is negative 4. All right, and if you wanted to, you could check yourself. We're not asked to in this problem, but we can check pretty easily. We're going to go back to the original equation, and anywhere we see an x, we're going to plug in a negative 4. So I get 2 times negative 4 minus 12 times negative 4. Hopefully that equals 40. Well, 2 times negative 4 is negative 8. And this minus 12 times 4, I'm going to think of that minus 12 as negative 12. So negative 12 times negative 4 is positive 48. And then negative 8 plus 48, I'm adding two numbers with different signs. I subtract their absolute values. So 48 minus 8 is 40. But I have to ask myself, is it positive or negative? Well, I have 8 negatives, but I have 48 positives. That means I have way more positive than negative, so the leftovers are positive, and we get that 40 really does equal 40. So we can say the final answer is negative 4. Okay, let's look at part B. So part B definitely has some steps that need to be taken, and this one is a semi-advanced problem here. We notice that we have variables on both sides of the equation. We also have constants on both sides of the equation, and this is a common thing you're going to do in the next worksheet where we're solving more complicated equations. We have to get all of the variables together, and we have to get all of the constants together before we can apply the multiplication property of equality. You have to have a single variable term and a single constant term. So let's address the variables first, okay? I have 2x on the left, I have negative 4x on the right. I personally, and most mathematicians, will move our variables to the left. We want that variable term on the left-hand side, okay? So if I look at the right-hand side, I have negative 4x. That's the same as taking 21 and subtracting 4x. So how would I undo subtraction? I would use addition. So I'm going to add 4x to the right and to the left, and let's see what happens. Well, the left is easy. I just have 2x plus 4x. 2x plus 4x is 6x. And don't forget that 15 that is still there on the left. So I'm going to drop down minus 15 equals. But then on the right, negative 4x plus 4x, that just becomes 0. Those x's kind of cancel each other out to just become 0. So I get 0 plus 21 is 21. So the good news is I have a single variable term, but it's not by itself. And in order to apply the multiplication property of equality, I have to have a single variable term equaling a single constant term. This minus 15 is an issue. So let's see what we can do to move the minus 15. Well, minus 15, that's subtracting 15. We would undo subtraction with addition. So I want to add 15 to both sides. Well, on the left, negative 15 plus 15 is just 0. We could say the 15's canceled. Just remember, we say cancel a lot. It doesn't mean things just like poof disappear. They either cancel to become a 0, like right here, or they cancel to become a 1. So negative 15 plus 15 is really just 0. 6x plus 0 is just 6x. And then on the right-hand side, I can just combine like terms. 21 plus 15 is 36. And if you look at this step right here, we now have a situation where we can apply the multiplication property of equality. We have a single variable term equaling a single constant term. So let's go ahead and see if we can isolate that x. In order to isolate x, we have to undo what has happened to it. So since x is being multiplied by 6, I want to divide by 6 to get the x alone. And if I divide on the left, I have to divide on the right. Okay, so on the left, 6 divided by 6 is 1. 1 times x is just x. Again, we would say a lot of times the 6's cancel. Just know they don't just disappear. 6 divided by 6 is 1. They cancel to become a 1. 1 times x is x. And then 36 divided by 6 is 6. So we were not asked to, but let's go ahead and check. Anywhere I see an x, I'm going to plug in a 6. So 2 times 6 minus 15 equals negative 4 times 6 plus 21. So let's see, 2 times 6 is 12. So we get 12 minus 15. Negative 4 times 6 is negative 24 plus 21. So if we go back to the left, 12 minus 15, you could think of this as 12. And instead of subtracting positive 15, we add negative 15. Which means we're adding two numbers with different signs. So we subtract the absolute values, we get a 3. 15 minus 12 is 3. And then because I have more negatives, I have 15 negatives and 12 positives, this is going to be negative 3. And then for the right-hand side, we have negative 21, negative 24 plus 21. Again, we're adding two numbers with different signs. We subtract the absolute values, which means 24 minus 21 is 3. But again, we have to determine if it's positive or negative 3. Since I have 24 negatives and only 21 positives, that means the leftovers when I subtract stay negative. So we really do get negative 3 equals negative 3, which is true. So the solution here would be 6. Okay, now I did say I was going to make just one video for the last two topics. So let's go ahead and look at topic 4, which is applications. So I do want you to get in the habit of learning how to solve problems. Okay, we're going to do a lot of problem solving in future sections, but I just want to kind of get you like eased into the idea. So for this example 4, it says use the information below to answer the following questions. So we have this graph, and it says the median weekly earnings for men with some college or an associate's degree in 1980 was $358. In 2016, it was $896. Okay. It then says, using today's dollars, the data in the bar graph can be described by the following mathematical model. Now, mathematical models are basically formulas that have real world backing. So the variables in the formula have some kind of real world meaning, okay? So we have M equals 15N plus 358, but let's read to see what those variables mean. We're told that M represents the median weekly earnings, and N is the years after 1980. So if N was 1, that would represent 1981. If N was 5, that would represent 1985. If N was 10, that would represent 1990. So be really careful with your N. Okay? So then let's go on and do part A here. It says, does the formula underestimate or overestimate the weekly earnings in 2016 and by how much? So the graph is telling us what the information is, but then we have this model that kind of best represents that graph. So when we talk about the formula or the model, they're the same thing, and that's going to be the equation that you see. So we want to see what the median weekly earnings would be in 2016. So let's do a little work first. We know that N equals the years after 1980. So for us, N is going to be 2016 minus 1980, okay? And you could do the side work, you can use a calculator, whatever you're comfortable with. I do want you to get to the point where you don't have to use your calculator all the time. But here, when we subtract, we know that to go from 1980 to 2000, that would be 20, and we add 16 more to that. So N in this case is going to equal 36, okay? So we want to take this model right here, and we want to replace N with 36 and see what the model gives us, and then compare that to the graph, okay? So M equals 15 times 36 plus 358. I do expect you to use a calculator here. 15 times 36, we could do the side work. You could also use the calculator. For the sake of time in this video, we're going to use the calculator. So 15 times 36 is 540. We want to add 358 to that. And again, this is going to estimate the salary, the median weekly earnings for men in 2016. So we want to add 358, and that puts us at $898. Now, let's compare that to the graph. So remember, this graph gives the median weekly earnings for men with some college or an associate's degree. And in 2016, the graph said that the actual median earnings were $896. So the formula overestimates the median weekly earnings in 2016 by $2. So that's pretty close, okay? So the actual information was the weekly earnings would have been $896. The model estimated it as $898. That's pretty close. It's an overestimate, but barely. Okay? So then it says, if the trend shown by the formula continues, when will median weekly earnings for men with some college or an associate's degree be $1,033? So we're going to have to do some solving here. So let's see how we feel about this. So now we're saying M is 1,033. So let's see if we can use these properties, the addition property of equality and the multiplication property of equality, to solve this. We're going to have to do a little work. This is a little advanced, but I think we can handle it. So we want to take that formula. Let me scroll up so you can see the formula again. We want to take M equals 15N plus 358, and we want to solve it, but where we replace M with $1,033. So we're going to get 1,033 equals 15N plus 358. Now, our goal is to get to the point where we can use the multiplication property of equality. And we can use the multiplication property of equality when we have a single variable term equal to a single constant term. We have a single variable term, 15N. It's not equal to a single constant yet because we have that plus 358. We got to deal with that plus 358. So we know from the previous worksheet, the addition property of equality, that we can move things around using addition and subtraction. Well, the problem we have here is this 15N that we desperately need to get alone has 358 added to it. Let's see if we can undo that. We can undo addition with subtraction. So let's subtract 358. Just keep in mind, if I subtract it from the right, I have to subtract it from the left. So again, I'll allow the calculator just for the sake of time. So we get 1033 minus 358. We get 675 equals 15N. And the reason we get just plain 15N is if you look at positive 358 minus 358, that just equals 0. 15N plus 15N plus 0 is just plain old 15N. So now we have 675 equals 15N. This is exactly what we need. We need a single variable term equaling a single constant term, and now we can apply the multiplication property of equality. We need to undo what has happened to N. We already undid the 358 that was added. Now we need to undo the 15 that's multiplied by N. We undo multiplication with division. Well, on the right, 15 divided by 15 is just 1. So we get 1N. And then 675 divided by 15 is 45. Now, we have N equals 45, but what does that mean? Remember, N is the number of years after 1980. So to figure out the actual year that the weekly earnings for men, when it would be $1,033, we have to take 1980 and we need to add n, which is 45. So 5 and 0 is 5, 8 and 4 is 12, so I keep a 2, carry a 1. 9 and 1 is 0, or is 10, bless my heart, it's 10. We keep the 0, carry the 1. 1 and 1 is 2. So we could say by 2025, the median weekly salary would be $1,033. Okay, so just be careful in an example like this. N is not exactly straightforward. You have to take N and then either add it or subtract it from 1980. So in this case, we add it. All right, so there you have it. We've done a few pretty involved examples here where we had to do multiple steps. So that's going to be the theme for the next worksheet. We're going to solve a lot of equations, a lot of different ways, and they're going to have a lot of different steps, okay? So get used to that idea of simplifying before you apply those two properties, the addition property of equality and the multiplication property of equality.